Hi, now we are going to do some more amazing stuff in Freecad, which is called a parametric design. So this is actually why Freecad is so powerful because, of course, in a really expansive commercial programs, you can do this kind of stuff as well, but also in Freecad, you can do that. So in order to show what I mean is, of course, we are opening again a Freecad, and now I'm going to do a new part. So I can go directly to part design. I will do this by using Sketcher, but technically speaking, in order to understand what is new here, I should start with something which is called spreadsheet. So it's simply like an Excel spreadsheet, but what it does is like we are going to define some different lengths or parameters, whatever we want, and then we are going to use them later on. Okay, so spreadsheet is, you can of course import it here as an import spreadsheet possibility. You can write it in another program like Excel, but you don't need that. So for many stuff you can create the spreadsheet here. So I'm doing it. I can leave the name as it is, or I can give it another name. So I'm going to use param, like parameters, and enter, and then I'm going to open it. Okay, it's just a simple, cells what you see here. Now I'm going to start. You'll see immediately what I mean, like length, for example. I may have like a width, and I may have also a thickness. So these are some names that I'm going to give. So these are not, I can give whatever I can also write A and B and C. I will not gonna use them. So what I'm going to use are the column B. So that means here the length will be, for example, 100, and again, for me, I'm taking a note, it is millimeter, but I'm not going to use C at all. So that Freecad doesn't know in which units I'm doing it. So I'm just using some numerical values here. And the width will be, I don't know, maybe 30. And the thickness, let us have like 2 millimeter thickness. Okay, so these are all something for me notes. What I'm going to use are these numbers. So now I want to see this one. So actually I want to see both of them, which is possible if I go to Windows, and I mean these are the windows of the Freecad, and you see here we have two different windows here in Freecad. So I can now say, okay, I want to have a tile, so they will be like, and somehow like one is left, one is right. So I can of course move them around, or I can make this one a little bigger because this is the main stuff that I'm going to use. So let me now start by doing a sketch. So either I can go to the part design, that's what we did, right? We go to part design, then we start a sketch, and then we do something on sketch, and then we use pad or extrusion or something like that. So now this is exactly the same. Or I can first do the sketch and then later go to the part design. There's no huge difference between them. So let me show that's exactly the same. Now I'm going to create a sketch, and it's saying like I cannot map the sketch to the selected object, because before I click on this, I was actually have left this param somehow selected. So this is freaky things that I try to do something on this, which is not the case. So I'm clicking somewhere else, right? So this is now not selected anymore. Now I create a sketch, and it now asks me, of course, in which plane. Technically speaking, doesn't matter. So I'm just taking one, and now I try to do like length, width, and thickness. So what I have in mind is just a simple plate. So I'm here using something like a rectangle. That's it. Now I want to use the dimensions. So we did it in order to close or make the degrees of freedom 0. So now I'm going to use actually the spreadsheet here on the left. So I'm now using like the dimension here, which is 89 point something. So what we have done was like just writing the values. I can write 100 and that's it. But no, I don't want to do this. I want to map this number with this B1 cell in the spreadsheet. So that means I want to give something like an expression. So here on the right, there's a small button, which is like an enter an expression. So I can click on that. Now I can do some mathematical operations here. So for example, I can do like 90 divided by 2. So it will understand me. This is still not what I want to have. I want to do like use this one and delete it. Now I want to use the spreadsheet, which has the name, internal name that I have given, param, right, like parameters. So if I try to write parameters, then it automatically asks me, oh, do you mean the spreadsheet, which is parameter? Yes, I want to have that. Then it uses a dot. That means inside. Inside I want to use B1. So I start writing B1, capital B, because this is capital B here. B1, right? Enter. So it automatically tells me which is 100. Yeah, I know that. And okay, right? So now I have, technically speaking, merged or combined this value, whatever the value here is the length of the plate. So this is the parametric design behind. So now I'm going to do exactly the same stuff, but this time, of course, for the other one, which is here, I'm going to again use this button here in order to write the spreadsheet param, and inside we have the B2. Okay, that's the sketch now, so I can leave the sketch. So let's close. I mean, of course, I can fix the degrees of freedom, but for at the moment, I don't care about the position really. So I can say close. Now we have a sketch. Now I'm going to go to the part design module, right? So here's the part design. And now, actually speaking, so I don't have a body here. So I can create a sketch, of course, but I don't want to have that. So I want to have actually a pad on this sketch, right? But now it's saying, hey, you don't have a body, so you cannot do this. So yeah, okay, let's create a new body. And I'm saying, but cannot use the selected object because this sketch is not belonging to the body. So you can see that actually here, there's a body and there's a sketch, there's a spreadsheet, but they are somehow, they don't have to do anything with each other. So what I want to have is actually this sketch supposed to be belonging to the body. So I'm simply drag and drop, putting into the body. Now it is part of the body. Now it belongs to the continuum body. And now I can select this and go to the task and say I want to have a pad. So for this, of course, the padding length, right? This is technically what I call thickness. So I can use exactly the same stuff. I can click here and write param. And for this, I want to use the B3. So this actually is right here. So B3. I say, okay, that's 2. So now we did it. Fine. Now you can ask, okay, what was the whole reason doing it? Now you're gonna see it. So let me change the thickness because it is somehow like, it is belonging to the thickness is given by this number, by this cell value of the cell. So if I use like 30, it will be thicker. So, or I can just make it like 5, for example. The width I can change to 45. It will be wider, or of course, say with the length. So by using a parametric design, technically speaking, later on, I can simply change the parameter without needing to do everything again. So we can even do some more complicated stuff. For example, I can select the surface here, and on the surface, I can create a sketch. And for example, let me do a kind of a, I don't know, maybe a circle. So I want to give the position of the circle, and in order to do this, for example, I can say the horizontal, first of all, I can say, of course, the circle diameter, and let's have the diameter like 10, and I can again here fix the diameter by using a constraint. There's a constraint which is called the constraint on arc or circle. This is exactly what I want. I click on the circle and the diameter is asked, again using the same stuff, like writing here parameter and B4. And now what I can do is I want to fix the position along this y-axis, and I can do this, for example, of course I can write it here something, right? That's possible. But I can also do is I can say the position of that. Oh, by the way, it's a little bit difficult to give the position because this is somehow not really, I cannot really reach like one point of that. I can try to turn it around so you can see it in 3 dimensions. This sketch and this is the 3-dimensional body here, they have nothing with each other. So I cannot really somehow use the corner or the position of the edge here. So what I'm going to do is like, let's close. it will remain there. Okay, so now I'm going to go back to the pad. You see on this 3 here on the body we have a pad, and inside the pad we have the sketch. So that's the old sketch that we use. I'm clicking in and I'm going again back to that. Now I'm going to change the position by fixing it. So I'm going to use one constraint here, which is like this position, the edge is technically in the origin, right? So by the way, now it's like green because the degrees of freedom are 0, so it's fully constrained. So close. Maybe sometimes it's good to make it fully constrained, right? So now if I go back to the sketch and then let me put it there and also shift it that we see everything. So now I have access to the origin, so that means now I can have a nicer way of saying the position of the middle point of the hole, right? So this one is something. I'm not going to use one of the cells. Instead of that, I'm going to use like depending on the width. So let me use, for example, the width is v2, right? So I'm writing v2 and then divided by 2. So I can use really like mathematical equations here. So that means that it's going to be in the middle. Whatever the width is, it's going to be in the middle. But for the, let's make it a little bit different. For the horizontal position, let's say like circle position, right? So these are some notes that I'm putting here in order to know later on what is what. And this is, for example, always like 25. So again, here I go and then say I want to use this constraint, which is a horizontal distance from the origin until the circle middle point, and this is given by this new cell that I put B5. Okay, so now if I leave the sketch, now I can do something with the sketch. This is the new sketch, right, that we have. I mean, it's not selected because of that, it's green. Now I can go to the task and say, let me make a hole, right? So I did a hole here. So you can see, so it's a hole. So now we can try to play around and then say, okay, what happens if the length will change? So the position of the circle is always the same from this end. So because of that, if I make it shorter, it doesn't change, right? So if I can even make it shorter, you see, there's no like error or something like that. It's parametric. You wanted to have the hole later than the plate, so that means there's no hole in the plate. So I can make it like a bit this kind of stuff. And I want to change the thickness, and I can of course change the diameter, circle position. So you see, I mean, it's also like changing the position of it. So that's the whole idea. So of course you can make it as complicated as you want. So this is generally speaking the idea behind the parametric design. So once you have the parametric design by using kind of an Excel sheet or a spreadsheet that you do it here, then you can later on change all the dimensions without redoing everything.